going to do things a little bit different with example 1. We're still going to do the question off to the side, but there's something important we need to notice in the main question as well, so we're actually going to do them both. But we'll start with the one off to the side. So the one off to the side, on our original graph here, we have 4 points. If we write them all down, we've got -5, 3, -2, -3, 1, 0, and 4, 6. We want to sketch the graph after compression of 1/3 and a translation 2 units up. So just like, we're going to do all of our stretches, compressions first, and then we'll do our translations afterwards. So remember, we'll do our stretches first, and then our translations. So do we have stretches, compressions? Yes. We need to multiply y by 1/3, and then we need to go 2 up. So our x values are never going to get changed here, so we got -5, -2, 1, and 4, 4, 1, -2, -5. Nothing's affecting the x's whatsoever. Our y's by 1/3, this is going to be 1, -1, 0, and 2. And then 2 up is going to change this to 3, +1, 2, 4. Now we're going to put all our points on here, and we're going to get a sense if we made any mental math errors along the way. So -5, 3, that point is exactly where it started. -2, 1, 1, 2, and 4, 4. Now, to get a sense if this is actually what it should be, go back and look at what are we going to do? We needed to multiply y by 1/3. That's going to compress y. Does our new graph look like it's the old graph being squished? So has this graph been squished? And then, after it's been squished, has it been moved up too? So that's one thing that you're going to do sort of just as a mental check. Does my graph look like the right kind of shape? Okay. So if I wanted to just check what the squishing would do on my graph, if I multiplied all my y values by 1/3, which is at 4, 6 to be a 2, that would be just the squish. And then has that been moved up to? Yes, it appears to have been correct. So you can do a little bit of a mental check that way just to see if our graph matches up. I'm going to write down the questions for this one, but then we're going to do the original question to see how it's different. Yes? All at the end? We can do that as well. So far. Okay, so in this one, and you've got the written solution there, so you can watch. I'm going to do it in the same way that we've done before. I'm going to look at the points. We've got -4, 3, -2, 0, 2, 5, and 4, 2. Set up our arrows. We want a horizontal compression by 1/2 followed by 3 to the left. So if I do that, I'm going to get -2, -1, 1, 2, and the y's will not change. Then 3 to the left, that's going to go to -5, -4, -2, -1. And so now we're going to plot these points. So we've got -5, 3, -4, 0, -2, 5, and -1, 2. And if we draw the lines in between them, this is the shape that we get. So, just like I did before, I want to think about, just one second, I want to think about, does this match up, or did we make a mental math error? Okay? X by half should squish it, right? And then we need to move it 3 to the left. See that something doesn't seem to match up? We've sort of got a problem here. This point, when it gets squished, would still be there. And when you move it 3 to the left, it should be down here somewhere. It doesn't seem to match up. So where did we make our mistake? Was I sneaky? Did you catch this? Some of you caught it. But did I sneak that one past some of you when I labeled that quickly? Yes. We made a mistake with this point. So all of this stuff here won't match up because it should have been 0, -2. Can you see yourself making mistakes like that? Yes. So that check thing is important for you to just sort of say, does it seem right at the end? Because yes, it's very easy to make mistakes like that. It's very easy to make mistakes with negatives as you're figuring things out as you go along. But now when we multiply x by a half, the y doesn't change, moving it 3 to the left, -3, -2, that seems more reasonable. Now, I didn't want to do just this one to make a mistake, to point that out of how you're check, but something actually happens that's different when you do things horizontally. When we go to write the equation for this one, did we write the equation for the last one beside the graph? Okay, we'll go back. Here's our first one. In our first one, it says sketch and label. We forgot to label it. When we go to label this one, we're going to have y equals a vertical compression of 1/3 would come out in front, g of x, and the translation of 2 units would come after, plus 2. So that would be the equation for the one that we did off to the side. Now for the equation of the main one, we've got y equals, everything is going to be inside the function. And we're going to need 2 sets of brackets because x by half is going to show up as a 2 multiplied. And you're going to be tempted to just write x minus or x plus 3 to go 3 to the left. But whenever there is a horizontal stretch along with a horizontal translation, it'll always have to be in factored form. So the x plus 3 has to be in its own brackets. So whenever I have 2 sets of brackets, lately I've been liking to use big brackets and little brackets. Sometimes people like to use some square brackets and some round brackets. Whatever you prefer will be fine. But do you still have some space at the bottom of page 221? So I would like to write at the bottom just a special note. And we're going to refer to this note a fair bit in the next couple of days. So whenever you have a horizontal stretch, compression, or reflection. With a horizontal translation. You must write it in factored form.